Like to spend the following few minutes to explain how to perform supervisor synthesis using Supermica. We will use during this video, in addition to Supermica itself, the following documents. One of them is related to the explanation of Supermica. It's called Supermica in a nutshell. And we will use another paper. It explains a benchmark problem. This is called the cat and the mouse problem. The nice and the important thing is that this problem, it's about the cat and the mouse. This problem is already programmed inside Supermica, or we have a ready-made example that's available when you install Supermica. When I refer to the documentation or this manual of using Supermica, and if I just search for the cat and mouse. Okay, so this cat and mouse example, as we could see, this example is a classical one, and you can open it from selecting examples, DAS book exercises, cat and mouse. This is what I'm going to illustrate right now. That's what I'm trying to illustrate. Okay, so as you could see now, I will click here on examples, DAS book examples, or yes, examples. Where is the cat and mouse? Examples or exercises, cat and mouse. So this is a brief description. It's about a cat and mouse. Of course, the cat will be an automaton and the mouse will be the other automaton. The cat and the mouse cannot be in the same room. Okay, as you could see here, you can see an automaton here for the mouse and another automaton for the plant. Before getting into more description, here I will refer back to the original documentation of the problem. So the problem speaks about a cat and the mouse. The main requirement here is that both animals can never occupy the same room simultaneously. Okay, it is always possible to the cat and mouse to return to their initial position. So I will show you the maze. This is the maze as you could see it. The maze consists of room number 0 and 1 and 2 and 3 and 4. We have here 5 rooms, 0, 1, 2, 3, 4. And we have doors, or we have exit and entries for each room. For instance, for this exit, okay, it is possible for the mouse to transverse this exit to go from room 0 to room 4. That's why it's written M4. And it is possible for a cat to route this exit. It's called C6. And somehow this notation may be confusing because C6 lets the cat transverse from room number 4 to room number 0. And the same here for C3, you can infer the only exit or the only door that can be transversed for both sides in this room, it is C7, that let the cat transverse from room number 1 to 3 and vice versa. As you could speculate, or as you could assume, or as you could think, each of these C7, C1, M3, M1 and so on, these will be events. Let us try to see how this was encoded inside Supermica. Let us have a look at the mouse. Initially, the mouse was located at room number 4. The cat in 2 and the mouse in room 4 initially. So the cat in room 2 and the mouse in room 4, let us have a look here. We can see here that the mouse is initially at room number 4. And then what happens if, for instance, M5 occurs? as you could see here, he's number 4. If M5 occurs, he goes to room 3. By the way, he cannot transverse to room number 0. So you can see here that this is written initially in M4. If M5 occurs, he goes to M3. I will try to put them side by side so that we could have develop a better understanding. Okay, so if the mouse is at room number 4, initially M5 is executed, he goes to 3, and from 3 he can only execute M6 to go to 0. As you can see, this is M6 where the mouse now goes to room number 0, and if the mouse is at room number 0, he has two options: either execute M4 to return back to 4, or execute M1 to return back to 2. And as you could see, this is M4 and M1. You could review and verify the idea also for the cat. Okay, so these are the automata, two automata, one for the cat and another one for the mouse, and they should replicate or describe the situation, as we could see. Now we have an important requirement here. What's the requirement? That the animals never occupy the same room simultaneously. Okay, so how can we enforce this, or how can we describe this? This is described in terms of these requirements. So let us have a look, for example, at any room. Let us have a look at the requirements of room 0. Okay, let us have a look at the requirements of room 0. What can we have here? So as you can see initially, room 0, it is written room 0 R0E. R0E means room 0 is empty initially. What about, for example, room 4? If you remember, room 4 was, this is room 4, okay? Room 4 was not initially empty. Room 4 was initially having a mouse. That's why you could see here. And if you have a look at room 2 initially had the cat. So these are the descriptions. Okay, let us have a look again at any one of them. Let us have a look at room 0 okay. So room 0 is initially empty. Okay, if this room is empty, then what are the stakes initially? If the room is empty, okay, I'm trying again to put the automata and the figure side by side. If room 0 is empty, then we can have one possibility that we can receive a cat by C6. So it is initially 0, and if C6 occurs, as you could see here, we can receive a cat. Or we can also receive a cat from C3. So C6 or C3, if they occur, we will receive a cat at room 0. We will have R0C. Okay? And if R0C occurs, we cannot receive a mouse. For example, M3 and M6 are not allowed, or M3 or M6, as you could see them, they are not allowed here. But what we allowed here is C1 and C4. We can allow the cat just to exit. Okay, C1 and C4. We can just allow the cat to exit. And you can check the same from the mouse side. If the room is empty, we can just allow the mouse to come in from M6 and from M3. As you could see, then the room, the state will be R0M, means that we are having a mouse in room number 0. And we cannot allow C3 or C6, we can just allow M1 and M4. This is the same methodology. The specifications are written for room 1 and room 2 and room 3 and room 4. You can verify that yourself. Okay? So if you refer now to the manual of using Supermica, he will be explaining, for instance, how to synchronize. Okay? And I will do the synchronization now. To synchronize, we will go to the analyzer, okay, and we will select the automata, and then we will synchronize them. and this is the resulting parallel synchronization, okay, or parallel composition. You will find here two red states. What is the reason for these two red states? These two red states are very dangerous, okay. What's the reason for that? Please refer back to the events. Please refer back to the set of events. If you can see here, this C means that the event is controllable, okay. However, this is not the case, for instance, for event C7. This is the single uncontrollable event. This is the single uncontrollable event. It cannot be stopped, okay. However, if for any reason, our system is in this state, we are subject or vulnerable to have a trouble. Why? Let us analyze thoroughly, okay. This state, it's called C3M1, is called R0 empty, R0E, empty room. R1 mouse, we are having a mouse at room number 1, okay. And R2 empty, room 2 is empty. R3C, we are having a cat at room number 3. So at room number 1 we are having a mouse, and at room number 3 we are having a cat. So what's room number 1 we are having a mouse, room number 3 we are having a mouse, room number 3 we are having a cat. At that situation, C7 cannot be stopped because it's uncontrollable, and it is possible that the system can reach a state that we are trying to eliminate, which is room 1 mouse, R1M and R1C. That's why the Supermica is intelligent enough, and he is telling us that we should try to eliminate or forbid this state. And this state also should be forbidden. So the question is how to forbid these states. These two states can be forbidden if we request Supermica to synthesize or to design a supervisor. That's what we are going now to do. I have selected all the automata, and then I will right click and I will select synthesize. Simply I will click OK. Now this is the new supervisor. We have synthesized the supervisor, and we have made sure that the dangerous states are eliminated, of course. It can, just for you to understand more, I will request Supermica to export, not to export. I will let him plantify. To editor, yes. So he has created the supervisor. So this is the plant, this is the requirements, and this is the supervisor. You can have a look at the supervisor, and he is telling you that he has blocked several events, C5, C6, and M1 and M2 and M3, to make sure that we will never reach the dangerous states. From these dangerous states, C7 will be possible, and he is trying to totally get out of this situation. So that's all with this video. Now you can understand what's the meaning of a requirement and how to describe the requirement in Supermica, and how to sense the supervisor to enforce this requirement and to describe the supervisor. Thank you for your attention.